torsion is something like a twisting of an object, which is because of the torque is applied on that object. It is something like you rotate the other one with anti-clockwise at the end of the material and the other one with the clockwise direction. So it will have the same force on every direction.
Okay, Assalamualaikum warahmatullahi wabarakatuh and very good morning. Our video assignment is Torsion. My group member is Muhammad Taufik, Muhammad Farooq Fahmi, Nur Arifah and me, Nur Akmal Shakila.
What is torsion? In general, torsion is twisting of an object due to applied torque. The unit is Newton meter or foot-pound force.
Okay, next we talk about internal shearing stress. Internal shearing stress is produced when the internal torque and the torque in the same direction or opposite direction. As you can see in the diagram above, when the torque is in opposite with the internal torque, it will produce the internal shearing stress. This is the formula for the internal shearing stress. And please take note that the distribution of stress is not included, although is involved with shearing stress. And the distribution of shearing stress due to torsional load is not uniform unlike the normal stress. And also the distribution of the shearing stress is typically intermittent, must consider sharp deformation.
Based on the diagram above, the torque is applied to the shaft. It will produce the shear stress on the perpendicular axis on the surface. This is application of shear stress. Okay, this is the slack slide. When the torque is applied at the both end of the shaft, the shear stress is equal from here to here. From the picture here, okay, the angle of twist of the shaft is proportional to the torque and to the length. Okay, for the circular cross section, it will be the undisturbed when torque applied. Okay, for the non-circular cross section, okay, it will be the disturbed when the torque applied. We can look here.
Okay, now I will explain about formula of shear strain. We will see that shear strain maximum is equal to directly proportional to the radius and angle of twist, but is inversely proportional with the length of the material. If you can see, this is the length of material and this is the radius of the material and angle of twisting when it is applied torque on that material. The torque maximum. Okay, firstly we can look the first equation from the shear modulus, shear strain, and then there is radius and shear strain and shear modulus maximum. So if we insert the Hooke's law into that equation, it will form this equation. And then after that, we will insert it into the first equation that we have revised before this. And then it will form this equation with if torque maximum is equal to torque multiplied by radius over J. Before this, I have told about J. What is J actually? J is polar moment of inertia. Polar moment of inertia, there is two types, which is the solid one and the hollow one. The solid one has different equation with the hollow one because the solid one have full material, full complete. So the polar moment is equal to 1/2 pi c power of 4. But for the hollow one, polar moment is equal to 1/2 pi c2 power of 4 minus c1 power of 4.
Okay, next we will explain about the torsion failure. in the torsion, we have two material, which is ductile and brittle material. When the torsion is applied on the ductile material, back in shear stress, which means that when the shear stress is applied on the ductile material will be cracked perpendicularly to the material axis. While the brittle material, when the torsion is applied on the brittle material, which is back in tension. When the maximum tension is applied on the brittle material, it will be cracked to the 45 degree.
Next, we talk about twist in elastic range. This time we will talk about how do we get this formula from the upper formula here. And you can see this shear strain is equal to radius times angle of twist over length, and also shear strain is also equal to tau max over G. So how do we get this formula from this formula? Tau max is also equal to TC over J. So if we insert the TC over J inside this formula, it will be TC over JG. From this formula, we can make into this formula. We also know that TC over JG is equal to C angle of twist over L, as that formula is equal to shear strain. To make this formula, the C, both C, we can cancel it, and the L, if this L we want to get into this side, we will go from bottom to upper side, so that we can get the angle of twist is equal to TN over JG. Basically this formula we use in summation form. To do the summation form, this is the formula for the summation form. Summation form is for this formula. The summation form can be sum of the TL over JG.
So next we explain about the stress of concentration. So when the normal stress is applied, we use this formula, which is tau max is equal to TC over J. When the shaft is have a coupling on the shaft, so we use this formula, which have K. K is stress concentration, which means when the coupling have all the stress is concentration on that coupling. So it have K. So the formula is tau max is equal to K times TC over J. To find this K, we must refer to the graph.
Which is we found in the helicopter, and when the torque is applied on the shaft of the turbo shaft, this turbo shaft, it will produce the torsion in this place, and on the above. When the torsion is produced, it will create a twisting force, which is it will rotate the helicopter blade.